गुड मॉर्निंग एवरीवन। कैसे हैं आप? हाउ आर यू ऑल? The class that I have taken yesterday about rotational motion, we have covered a lot of topics. Now, in today's session, we will continue from there and cover the entire chapter. The topics that we are going to study today are also very important. In yesterday's class, we have completed torque, I think. So, torque, you should remember, and we will start from the equilibrium of the body. Okay. So let's start. I hope everyone is there. Okay, tell me if my audio is clear to you. Is it audible completely? And then we will move further. Very good. Okay, so let's start. From here, we have to start mechanical equilibrium of a rigid body. So whenever someone is talking about mechanical equilibrium kind of thing or equilibrium kind of thing, that means equilibrium itself means acceleration should be zero. Equilibrium means acceleration should be zero. And what is the meaning of acceleration? A body may have two kinds of acceleration that we can see. One is translational acceleration, another is rotational acceleration, or you can say angular acceleration. So mechanical equilibrium can be divided in two parts. One is translational equilibrium, and another is rotational equilibrium. But in both the cases, acceleration should be zero. In case of translational equilibrium, acceleration is denoted by linear acceleration, that is A. That means A should be zero. But in case of rotational equilibrium, what is angular acceleration? That is alpha should be zero. Alpha zero doesn't mean that body is not rotating. It may be rotating with constant velocity. It may be rotating with constant velocity. Acceleration zero doesn't mean that body is at rest. The body may be moving with constant velocity. That means acceleration, whenever acceleration is zero, two possibilities are there. One is body is at rest, another is body is moving with constant velocity. This is the meaning of acceleration zero. Whatever may be the acceleration, it is angular or linear acceleration, but meaning remains the same. Okay, moving further. For acceleration to be zero, what you know that net force should be zero. And for alpha to be zero, who rotates the body? Who is responsible for creating the acceleration? You know that torque is responsible for that. That means net torque should be zero. So whenever someone asks you that body is in equilibrium, so what are the conditions you can apply there? You can apply these two conditions. Whenever the body is at rest, you can use F equals to 0 for translational equilibrium and tau equals to 0 for rotational equilibrium. And by using these two equations, you can solve any of the questions of this equilibrium problem. Any of the questions. What you need to do, you need to calculate, you need to find all the forces. Let's suppose there are three forces, but the sum of these three forces should be zero. And let's suppose here net torque is zero. What does it mean? That if a body has a lot of forces, then torque of all these forces will combine to zero. I will give you an example. Listen to me. Till now, everything is clear, no? What is the meaning of mechanical equilibrium? Okay. Now take an example. Let's suppose this is a rod. Clear? This is a rod. And this rod is hinged at the midpoint. What is the meaning of hinged? This rod can rotate if some forces are applied and will rotate either in clockwise direction or in anti-clockwise direction. Clear? It can rotate by applying some forces. It is hinged like that. This rod is hinged at the midpoint. It can rotate this way. It can rotate this way, this way, this way. This is how hinged work. Okay. Now listen to me. Let's suppose if force F1 is acting in this direction, another force F2 is acting in this direction, another force F3 is acting in this direction, and F4 is acting in this direction. Now, and someone is claiming, or the question is claiming that the body is in equilibrium. Okay, okay, okay. That's F2. Very good. Okay. F1, F2, F3, and F4. These are the four forces, and someone or question is claiming that the body is in mechanical equilibrium. What does it mean? That sum of all these forces should be zero. We have taken a sign convention in the previous classes that the force which is in upward direction will be positive and the force in the downward direction will be negative. So for that, or we can say for translational equilibrium, what you can say, upward forces are two only, F3 and F4. And downward forces are F1 and F2. The sum of these forces, or you can say the vector sum of these forces is zero. This is how you can use translational equilibrium. Is the statement clear? Now come towards rotational equilibrium. For rotational equilibrium, okay. If I talk about rotational equilibrium, what does it mean? That net torque should be zero. Now let's take or consider about torque, about net torque. Okay. I am just naming. Do you know the formula for torque? Torque is equals to R into F, or you can say R perpendicular into F. So R perpendicular you can find here for F1. This is the point of application. This is the origin. So R1 will be something like that. This is R perpendicular into F. So for every force you can write it. Now the thing is that let's suppose torque of F1 is tau1. This is tau2. This is tau3. And this is tau4. Okay. All torques I have named. Shivaji. Hello, Shivaji. Now, again, listen to me. When you are calculating torque, or you want to calculate, use the sign, which torque is positive, which torque is negative, just focus on the force of which you are calculating torque. Now I am calculating torque of F1 and my focus is only on F1. Now imagine in your mind, if this force F1 is applied on the rod, all other forces are absent. Then in which direction rod will rotate? You can see that this F1 force is similar to this situation and rod will rotate like that. Or you can see rod will rotate in the clockwise direction. So whenever a force or a torque tries to rotate a body in clockwise direction, it is considered as positive. This is a sign convention. You can take opposite to that as well, but don't confuse yourself. So what I'm saying, tau1 is positive if a body rotates clockwise. Now, if you consider F2 only, then it will rotate the body in the anti-clockwise direction. So tau2 will be negative. Tau2 will be negative. Clear? Similarly, if you talk about F3, can you see that if F3 is there only, it will rotate the body in the anti-clockwise direction. So tau3 will be again negative. And similarly, tau4 will be positive. So what you learned from this? You learned that if a body rotates clockwise due to a torque, then that torque is taken as positive. If it rotates the body anti-clockwise, then the torque will be considered negative. So how many torques are positive here? Tau 1 and tau 4 are positive. So you can write tau 1 plus tau 4 minus tau 2 minus tau 3 is equals to 0. You can form the equation in this way and you will get the desired answer according to the question. Now it's time to practice these things in a question. Let's move towards the question. Till now, if you want to ask something, you can ask, or you should write these things on your board or on a screen. Uh, you can write it that when to take positive, when to take negative torque. Moving further. This is a question. The language itself seems very long, very lengthy. So sometimes students may skip this, but I will suggest don't do that. Question says, a uniform rod of length 200 centimeter and mass 500 gram, this is gram, is balanced on a wedge placed at 40 centimeter mark. Now, listen to me. Question is saying that this is a uniform rod and this is a wedge on which it is supported. That means it is supported by this point. At this point, it is supported. And this support is at 40 centimeter mark. That means this total distance is 40 centimeter from this one to this one. Okay. Next, it is saying a mass of 2 kg is suspended from the rod at 20 centimeter. A mass of 2 kg is suspended from at 20 centimeter mark. That means this distance is 20. This one is 20. Clear? Now, can you sense or can you see that this distance will be what? This distance will be what? Can anyone answer? You can, I think. What will be this distance? Total is 40. This one is 20. This one is also 20, no? Very good, 20. Okay. Now again, read the question again. And another unknown mass M is suspended from the rod at 160 mark. Okay. So this total distance, I will say, from here to here is 160. Okay. As shown in the figure. Find the value of M such that rod is in equilibrium. Find the value of M. They want us to calculate the value of M such that rod is in equilibrium. Whenever they are saying equilibrium, that means they are talking about mechanical equilibrium. That means both the equilibriums are there. Now listen to me. I will take rotational equilibrium, and for rotational equilibrium, tau net should be 0. Tau net should be 0. So first of all, whenever you are doing such questions, identify the number of forces. Identify the number of forces. First thing is, you can see that if this is 2 kg block, then it will exert a force of 20 Newton. Is it clear? Mg. Force is what? Mg. So it will exert a 20 Newton force. Very good. It will exert a force mg. Again, very clear. Now, one thing to be sure, rod also has a weight. That is 500 gram is its mass. So it will also, its weight will also act. And the point at which weight acts is known as center of gravity. Is known as center of gravity. That means its weight will also act like this way. And this weight will act at a distance of hundreds at the point 100 centimeter. Why 100 centimeter? Because midpoint. The length of the rod is 200 centimeter. So the midpoint will be at 100 centimeter. Clear now? So this distance is going to be 100 from this end to this end. Okay. Now everything should be clear now. Okay. Now we have to calculate this value of weight will be. So the weight of the body is W is equals to mass into G. Mass is 0.5 kg into G is 10, that is 5 Newton. That is 5 Newton. Okay. Now we will calculate torque. So how many forces are there? One more thing, if I add, however, in this question, it is not necessary to write, but I will write because the concept should be clear. Let's suppose you can see a rod is placed at your hand, a heavy rod is placed on your finger. Can you see that the some part of this force, some part of his weight is felt by your finger? That means some action is there. And if action is there, that means it will exert a reaction. That's what I'm saying. This wedge will exert a reaction R on the rod. These are the total number of forces 1, 2, 3, and 4 if you count. So the sum of these 4 torques should be 0. Now for torque, you need to calculate the perpendicular distances. Now I will take torque. So first of all, you should decide your origin about which point you are taking torque. So let's suppose I am taking torque about the wedge, about the wedge, about which rod is going to be rotated. About that point, I am taking torque. Now, let's write the distances from the wedge. If you are taking torque about wedge, then all the distances you should know from the wedge. Now calculate the distances. I will use a different color, let's suppose white color pen. Okay. So distance of this 20 Newton from the wedge is 20 already known. Clear? Now find the distance, this distance, anyone. Can anyone tell me this distance? Because I am calculating distance of 5 Newton from the wedge. Can anyone tell me this distance? 20. Okay. Anyone else? I have told you now, this 5 Newton will act at the midpoint of the rod. If it is acting at the midpoint of the rod, that means it is at the 100 centimeter mark. If it is at the 100 centimeter mark, you know that this distance is 40. From here to here, it is 40. However, in the diagram, it doesn't look like that. But the remaining distance should be 60. Should be 60 to cover the entire 100 centimeter mark. Listen to me again, what I'm saying. This 5 Newton is the gravity force, is the weight of the rod, which acts at the midpoint. So if this one is 40, this one should be 60. Total is 100 centimeter. Now again, this mg, the distance of this mg from the wedge, that means this distance I am talking about. Can you find? Total is 160. Okay. From where we are calculating? We are interested in calculating the distances from the wedge about which we are taking torque. About which we are taking torque. So for this point, the distance will be total is 160. Out of which 40 is gone, that means it is 120 centimeter. Now we know all the distances. Now we know all the distances. Let's write torque of all these. Let's suppose it has a torque tau 1, it has a torque tau 2, it has a torque tau 3, and it has a torque tau 4. Now tell me which torque is going to be positive and which torque is going to be negative. I am asking one by one. What about tau 1? What about tau 1? Will it be positive or negative according to the previous discussion? According to the previous discussion, will it be positive or negative? Ritu is saying negative. Very good, Ritu. It is negative because this tau 1 will rotate anti-clockwise. So tau 1 is negative. Now what about tau 2? Reply quick because I am not moving further without your answers. It is a mandatory thing. Two persons have replied. Ritu is saying positive. Okay, listen. About which point rod is rotating? It is rotating about this point. This point. That means rod is hinged at this point and rotating about, and the force is acting in this direction. So rod will rotate in clockwise direction. And if it is clockwise direction, it will be positive. Similarly, tau 3 will also be positive. And what about tau 4? Tau 4 will be 0. Why 0? Because the force that is acting on this point has no perpendicular distance from the observing point, from the wedge. It is on the wedge. That means perpendicular distance is 0. So now I can write minus tau 1 plus tau 2 plus tau 3 is equals to 0. Now we write the value of tau 1. Minus is there. Tau 1 is equals to perpendicular distance, that is 20, into force, that is 20. That is 20 into 20. Plus tau 2 is what? Perpendicular distance is what? We have calculated it as 60. 60 into force is what? 5. Plus tau 3 is what? Perpendicular distance is 120 and force is what? mg is equals to 0. Now you can calculate. It is minus 400 plus 300 plus 120 mg is equals to 0. Can you see that 120 m or g is also 10 is equals to 100. So this 0 and this 0 is cancelled. So m will become 1 by 12 kg. Which option is this? This is option number A. Very good, Veena is saying negative. Very good, Veena, for tau 1. Okay, is it clear now? Such kind of question, there is another variety, that kind of seesaw kind of variety. Seesaw type of questions is also there. Another question is, they will ask you the value of reaction. They will ask you the value of R. If they are asking the value of R, then you should apply net force should be 0. That means translational equilibrium. And after doing that, you will get the answers. So till now, you can ask me if you want to ask anything from here. Otherwise, moving further. This question is not difficult. You can see that I have taken a lot of time in explaining the things, but the question itself takes 1 or 2 lines. That's it, nothing else. Now we are talking about angular momentum. This is again a simple thing. Angular momentum is nothing but L is equals to vector R cross P, where P is the linear momentum. Let's suppose this is our XY axis. A particle is moving something like that with some momentum P. This is origin about which we are interested in calculating angular momentum. Then join this point. This is going to be our R. This is our P. This angle is theta. Then angular, you can say L is equals to R perpendicular into P. With the examples, it will be clear how to get the directions and how to get the value of angular momentum. But the thing is to be remembered is this formula for you, L is equals to R cross P. Now again moving further, if I talk about for a body, for a rigid body. This angular momentum is written as by capital L is equals to I into omega. I into omega. This formula you should remember. This is the formula for the angular momentum of a body, where I is the moment of inertia, omega is the angular velocity. Now, if we are starting to talk about moment of inertia, then answer me, what is the moment of inertia? One more thing that we can say here is that if you focus that translational things and rotational things are somewhat similar. In translational motion, what we write as rate of change of momentum is equals to applied force. Clear? That's what we have used. This is Newton's second law of motion. Now, in rotational motion, we can use similar analogy and we can write this is what rate of change of linear momentum. So we can write rate of change of angular momentum is equals to force and the quantity which works same as force in rotational motion is torque. This is again a very important relation. dl over dt is equals to tau, where tau is the net external force, next net external torque. Tau is the net external torque. Clear? This relation you should remember. Write it down. This relation you should remember. Write it down. Now moving further. Conservation of angular momentum. We will describe this diagram right now. What is conservation of momentum? Conservation of momentum says if net external torque on a body is zero, if net external torque on a body is zero, then its angular momentum is conserved or will remain constant. This is the statement of conservation of angular momentum. Now again you can say angular momentum is nothing but I omega is equals to constant. Don't worry, just connect these points. L is equals to constant. L is what? I omega. I omega is constant. That means you can say omega is reciprocal to moment of inertia. This is again a very important relation. Omega is reciprocal to moment of inertia. Now, if I say, what is the meaning of this? The meaning of this is, if moment of inertia decreases, then angular velocity increases. That means, look at this diagram. This is a person. Look at him. He is rotating on a stool, on a rotating stool with dumbbells in his hand. Look at the dumbbells. Now, let's suppose he is rotating with some velocity, some angular velocity omega. Now, what he did in the second diagram, he folds his hands. And now you can consider if he is rotating, the axis of rotation will be something like that. This is the axis of rotation. Now you can see again the axis of rotation is same about which he is rotating. Can you see the distance of mass? The distance of masses here is more from the axis. That means mass is at far distance from the axis. In this situation, mass is closer to the axis. That means moment of inertia of this person decreases. I is decreasing. If moment of inertia is decreasing, can you say that moment of inertia is decreasing, then its angular velocity will increase and he will start moving faster, faster, faster. This is the thing that you can see more often in skating, more often by the dancers. Uh, the final step of the dance move is the circular rotation. I'm talking some gymnastic kind of dance. So in this final step is just rotation. So in that situation, the dancer generally folds her hand. And if she is folding her hands, that means she is decreasing her moment of inertia. She knows physics better than you and better than more other persons. Because after folding her hands, she decreases her moment of inertia and his or her, whatever, whoever the person is, his angular velocity increases and will be able to rotate for the longer times. That's why conservation of angular momentum, the necessary condition for that is net external torque should be zero. And if it is so, then I omega is constant. That means product of I omega is constant. If I increases, then omega decreases. If I decreases, then omega increases. As simple as that. There is a lot of variety based on this. I will discuss a simple question. Question is on your screen. Two rotating bodies A and B of mass m and 2m with moments of inertia IA and IB have equal kinetic energy of rotation. That means there are two bodies. They have masses m and 2m with moment of inertia IA and IB. IA and IB. They have equal kinetic energy. Equal kinetic energy means if you talk about kinetic energy of rotation, you can write it as, let's suppose this is Ka, this is kinetic energy of B. And both the kinetic energies are equal. The formula for the kinetic energy is half I omega square. Clear? Is equals to half I omega square. For A, the moment of inertia is Ia. This is omega A. This is IB. This is omega. Clear till now? Now, half and half will be cancelled. They are talking or they want us to calculate the relation between LA and LB. LA is the angular momentum of A and LB is the angular momentum of B. So whenever angular momentum is asked, you know that angular momentum is I omega. For angular momentum of A, it is IA omega A, IB omega B. This is not a big deal. Now you know the LA and LB relation. You want a relation between them, then you should divide these equations. And if you divide these equations, you will get this relation IA, IB, omega A, omega B. Now, from this equation, we can get omega A over omega B. Let's get this. From this equation, we can get omega A over omega B is equals to. I think your calculation part is not that weak. It will be IB by IA under root, if I'm not wrong. Put this value, then LA by LB will become IA by IB into omega A by omega is equals to under root IB by IO. It will finally become LA upon LB is equals to under root IA upon IP. IA will create under root here and here. So now you can see that this relation that we have got. Now, one thing to be sure that they are saying IA is less than IB here. IA is less than IB. If IA is smaller than IB, that means LA should be smaller than LB. So the conclusion is LA should be smaller than LB. If angular momentum of A is smaller than angular momentum of B, then out of these four options, which is correct option? Which is correct option? You can see the correct option is B. No, no, LA is less than LB. LA is less than LB. This is the relation. LA is less than LB. You can see here LA is greater than LB. No? So C option is correct. Option C is correct. Clear? Moving further. Radius of gyration. Very good, Veena. C. Radius of gyration. Okay. The definition thing might be confusing for you, but I will try to explain it to you. Listen to me very carefully. Focus. Let's suppose this is a rod which has some mass m and length L. Radius of gyration is, and we are interested in moment of inertia about this axis. You know the moment of inertia about this axis, ml square by 12, I think you know. Now, what is radius of gyration is, if we draw an imaginary ring of the same mass, listen to me, if we draw an imaginary ring of the same mass and the moment of inertia of that ring is equal to the moment of inertia of the rod about the same axis, then the radius of the ring is known as radius of gyration. It's a very difficult thing to understand. What I am saying, you have different kind of bodies: a cylindrical body, a spherical body, solid sphere, hollow cylinder, whatever kind of body, some irregular shaped bodies. So for simplicity, what we have done, we have made a concept of radius of gyration. After using this concept, we will convert every body means rod, whether it's sphere, solid sphere, whatever it is, we will convert it into a simple ring of same mass and the same moment of inertia. So the complexity of the question can be decreased. Complexity of the question can be decreased. So radius of gyration is what? It is the radius of imaginary ring. Radius of imaginary ring. I think this part will not be visible. I am writing it here. Which have same mass and moment of inertia about given axis. Why we do so? We do so because for there are variety of shapes. To bring some, you can say the term, एक जैसा बनाने के लिए, I don't remember the exact term for that. So we use the radius of gyration. How is it calculated? Let's suppose this K is the radius of gyration. That means K is the radius of that imaginary ring. Then moment of inertia is equals to mk square, where I is the moment of inertia about the given line. Radius of gyration. Don't worry. Don't get confused. I will tell you how to calculate that. I will tell you. By an example. Examples is, you must remember this relation and must remember this term. I is the moment of inertia. Okay, listen. Question says, find the radius of gyration of a thin uniform rod. Thin uniform rod. Okay, this is thin uniform rod of length L and mass M. Clear? About an axis passing through the end of the rod and perpendicular to it. That means about this axis, we are interested in calculating radius of gyration. We know that the moment of inertia of the rod about this axis, I is equals to ml square by 3. You should remember this relation because otherwise it will be very difficult for you. Now, ml square by 3 is the moment of inertia of this rod about the given axis. Now, according to the concept of radius of gyration, I should be equals to m k square. Put the value of I, that is ml square by 3 is equals to mk square. M and m will be cancelled. So k will be what? L by root 3. K will be what? L by root 3. Moving further, you can calculate radius of gyration for anything. This is important concept. Now come to rolling motion. Rolling motion. Listen to me very carefully. There are few punchlines and it will be done. The combination of translational and rotational motion is called rolling motion. Like the wheel that you see in your bike or in your car, whatever you have, the wheel of the vehicle is doing a rolling motion. It is moving in the forward direction and it is also rotating. So combination of translational and rotational motion is called as rolling motion. One thing is clear. Now, let's suppose in translational motion, let's suppose this is a body rotating in horizontal direction with some velocity v, then every point on this will be moving with same velocity v. This is the pure rotational motion. Body is rotating, just rotating. That means this point will be rotating, this point will be moving this direction. If this is rotating, then you can see that topmost point is going right, bottommost point is going left. If you combine these forces, what you will get, this is moving with velocity v, this point will be at rest, and this point will be moving with velocity 2v. This is the punchline that you should remember, that in pure rolling motion, the velocity of the topmost point is 2 times the velocity of the center of mass or velocity of the center. This is the punchline, just note it down. And velocity of point of contact is always 0. It will take a longer time to explain. So I'm not explaining these things that how it happens, but remember it in your mind. Only that will be enough. Topmost point will have a velocity 2v, bottommost point will be at rest, and center of mass will be moving with velocity v. Now, punchlines. First punchline is the velocity of point of contact is 0. Second is the velocity of center of mass is v. Then velocity of topmost point is 2v. Now listen. This is the body. This is the point of contact. This velocity is v. This velocity is 2v. Out of these, v is equals to what? R omega. Remember, v is equals to what? R omega. That means topmost point moves with the highest velocity. This is the simple punchline. Now, few more things that I will describe here. What is the kinetic energy of rolling motion? In rolling motion, there are two kinds of motion. One is translational, another is rotational. So when you talk about kinetic energy of rolling motion, there will be two kinetic energies, one due to translational motion, one due to rotational motion. I think it is clear to you. How it is calculated? The formula for that is on your screen. The formula says K is equals to half m VCN square. Don't confuse with VCN. VCN is the velocity of the center and which is denoted by V and whose value is R omega. Whose value is R omega. So don't get confused about the term VCN. It is nothing but the velocity of the center, which is V, and this value is R omega. Write down everything. The relation is half m VCM square 1 plus K square by R square, where K is the what? Radius of gyration. Radius of gyration. R is the actual radius of the body. And if we talk about what is the ratio of K square upon R square, it is fixed for certain bodies about their genuine axis. You can remember this relation. You can remember this, and that will be very beneficial for you. I will show you how it is beneficial. First of all, remember this. K square by R square is 1 for ring, 1 by 2 for disk or solid cylinder, 2 by 3 for hollow sphere, 2 by 5 for solid sphere. Revise, revise, revise is the only way you can remember this. Moving further. Rolling on an inclined plane. Again, this is a very important relation. I have seen the PYQs and a lot of questions are coming from this point only. What will be the time? Okay, listen to me. Let's suppose this is an inclined plane of inclination theta and height h. A body is rolling down the incline. A body is rolling down the incline, then from top to the bottom, what will be the time taken to reach? That time taken to reach is 1 over sine theta, 2h over g, 1 plus k square by r square. Now the question, how the question will come is very important. What they will do, you can see that they will say that it is a ring. They will say there is a disk or there is a solid sphere. And they will ask you which of these will come earlier, which of these will take lesser time or will take longer time to reach the bottom. Question is clear. There is a ring, there is a disk, and there is a solid sphere. Three bodies are there. They rolled it one by one. Then which of these three will take lesser time? So for that, you can clearly see theta is same for everyone. Theta is the angle of inclination that is same for everyone. Height is also same for everyone. G is also same. G is the you can say is constant 9.8. Now the thing is depending only upon k square by r square. K square by r square. The body which has more value of k square by r square will take longer time. So from the previous diagram, you can see that k square by r square is maximum for ring. That means ring will take longer time to reach the ground. Ring will take longer time to reach the ground. And its value is minimum for what? For solid sphere, its value is 2 by 5. And for disk, its value is 1 by 2. So again, solid sphere will take least time. This is the previous year question kind of thing. So you should remember this relation. And this question is very famous. Question is very famous. Moving further. It's only up to you how you can remember this relation. Otherwise, if you go with the derivation thing, it will take a longer time. So I recommend you to remember this relation, write it down. Because all these things are constant, only k square by r square on which it depends. You can learn k square by r square. That's very easy. Moving further. Minimum friction required for pure rolling. Minimum friction required for pure rolling. For example, this is a body which is rolling down the inclined plane. Then what should be the value of mu so that the body just rolls and without slipping? It rolls without slipping. Okay. For that, the condition is mu should be greater than or equal to this value. Mu should be greater than or equal to this value. If mu is greater than this value, then it will be pure rolling. If mu is less than this value, then body will skid with rolling. It will slip with, along with rolling. Sometimes it slips, sometimes it rolls, slips. Not pure rolling. This is the condition. How you can use it? Let's suppose I'm talking about for solid sphere. If I talk about for solid sphere, you want to calculate mu. Then mu will be greater than or equals to tan theta by 1 plus r square by k square. You know that value of k square by r square. for solid sphere is 2 by 5. You can remember this is 2 by 5. Very good. K square by R square by K square will be 5 by 2. Very good. So that will be 5 by 2. Can you see that it will be 2 plus 5, 7 by 2? So what it will become? Mu should be greater than or equals to. This 2 will go upward 2 by 7 tan theta. That means you can get for any body, for a sphere, for a cylinder, for any body, you can get the minimum friction required. Or you can say mu minimum frictional coefficient should be 2 by 7 tan theta. Now someone is asking you that if this mu minimum or this mu is, let's suppose, 1 by 7 tan theta, will the body roll, or will there be pure rolling, or there will be a skidding along with the rolling? If mu is 1 by 7 tan theta, will there be a skidding along with rolling, or it will be a pure rolling? You can say that mu is less than this value. Minimum value of mu is 2 by 7 tan theta, but the given value of mu is 1 by 7 tan theta. That means body will skid or will slip along with rolling. There will be no pure rolling. Clear? Okay. So you can get it for any different bodies. Now there is a question. A disk, a sphere of same radius but different masses rolls of two inclined planes of the same altitude and length. That means angle of inclination is same. Which one of the two objects get to the bottom of the plane first? That means which will take lesser time. So for that relation, I have told you to identify this relation. And I think you will get the answer correct. I am not going to discuss this question because mass is independent or time is independent of mass. How heavy is the body is doesn't matter. What matters is the ratio of k square by r square. Radius is same, so you can get the answer. Option is D. Someone is saying option is D. Okay. So that's up to you that which option you are getting. No, it's option C. Uh, Someone is saying option C now in YouTube. Veena is saying option C, I think. You will get the answer by using that formula. Right now, I am moving on a different question. This question will take some time and some concept here. What it says is solid cylinder of mass 2 kg and radius 50 centimeter rolls up an inclined plane of angle of inclination 30. First of all, draw the diagram. This is the inclined plane. And there is a solid what? Solid cylinder. If you see, it will look like that. It is a solid cylinder. We will remember this in mind. This solid cylinder. Inclination is 30 degree. Okay. The center of mass of the cylinder has a speed 4 meter per second. This point has a speed 4 meter per second. The distance traveled by the cylinder on the inclined surface will be the distance they are talking about, the distance it has traveled. Let's suppose it has reached up to this point before stopping. It has reached this point before stopping. And let's suppose this height is h. Okay. Now, what we can do to calculate the distance? Let's do it. Okay. What we have assumed here that this body or cylinder has reached up to a height h. This height we have taken as h. But We are not interested in this h. We are interested in the distance moved on the inclined plane, that is, let's suppose L. We are interested in calculating L. One thing is for sure, that from work energy theorem, I think you know the work energy theorem, work done is equals to change in kinetic energy. Work done is equals to change in kinetic energy. What is the work done? Work done is what? Its weight is mg downward and it has moved a distance h upward. That means work done will be minus mgh is equals to change in kinetic energy. That is k final minus k initial. K final minus K initial. If I talk about final energy, it is at rest finally. That means final kinetic energy is zero minus initial kinetic energy. It will have two kinds of kinetic energies. It will have two kinds of kinetic energies. One is translational, one is rotational. And in rolling motion, what is the value of kinetic energy that we have discussed on the previous slide? That is half mvcm square, 1 plus k square by r square. You can see it here. The kinetic energy of rolling motion is this one. So I will write the values there. Half m v square 1 plus k square by r square. Clear? You can see that m will be cancelled, minus will be cancelled. So it will be g into h is equals to half v square 1 plus. For solid cylinder, what is the value of k square by r square? You can see that for solid cylinder, k square by r square is 1 by 2. That is 1 by 2. If I change the color of pen, it will be V is what 10 into H is equals to 1 by 2. V is what center of mass has 4 meter per second, that is 16 into that will be 3 by 2 if I'm not wrong. So that will be 12. So H is equals to 12 by 10 meter. This is H. Now this is H. We are not interested in H. We are interested in L. So how L can be calculated? You can see that H is perpendicular. In this right angle triangle, H is perpendicular. Perpendicular is what? Hypotenuse into sine theta. So L will be, H is what? 12 by 10 is equals to L, and sine 30 is what? 1 by 2. 2 5s are 10. So L will be, you can divide it. You can divide it 5 into 2.4 meter. 2.4 meter is the answer, which is option number B. 2.4 meter is the right answer. You can understand how to use these things because this question involves work energy and power with the translational motion or rotational motion or with the rolling motion. Now, this is the question asked by someone in the previous class, that what is Lemmy's theorem? So in this topic, if you know the Lemmy's theorem, then it's up. Who has asked Lemmy's theorem? Is she present? Is she or he present today or not? Should I? Okay, let's wait. If okay, you are here. Okay. So what is Lemmy's theorem? Lemmy's theorem is, if I describe it in a simple way, if at a point there are three forces, listen to me, if there are three forces acting on a same point, and such forces which are acting on the same point are known as concurrent forces. One thing is clear. And the body is in equilibrium. Equilibrium, you know that body has no acceleration. Only then this theorem is valid. Clear? Body is in equilibrium and three concurrent forces are acting on the body. Let's suppose according to the diagram, three forces F1, F2 and F3 are there. and the angle between these forces are alpha, beta, and gamma. Then what it says, the ratio of force opposite with the opposite angle, F1 over sine alpha, F1 over sine alpha is equals to F2 over sine beta. This is F2 over sine beta and F3 over sine gamma. This is the Lami's theorem. How it can be used in any question? That's what I am explaining in the next slide. First of all, when it is to be used, there are three concurrent forces. Concurrent means acting at the same point, and the body is in equilibrium. Only then it is valid. Now, example based on this, find the tension. Question is find the tension in each string. How many strings are there? 1, 2, 3 strings are there. And they are asking you to calculate the tension in each string. Let's suppose. Let's suppose in this string tension is T1, T1. Clear? This is tension T2. This is tension T3. This is the point. Can you see that in the whole setup, the question, according to the question, this point remains intact. That means the diagram will look similar all the time. Then we want to calculate T1, T2, and T3. This system is in equilibrium. Now you can say, if you can say this is 30, so this will be 300 mg. Mg thing is clear. Now, from this diagram, you can say for 30 kg block, this block is in rest. That means T1 is upward force minus 300 is equals to 0 from Newton's second law. That means T1 is equals to 300. We got one tension. That is T1 is equals to 300. Now we will use Lami's theorem. For that, we should know some angles. If I calculate the angles, can you see that this angle will be 37? Alternate interior, this is 37 given, this will be 37. Now, this is 90. Clear? The angle between T1 and T2, this complete angle will be, I will write 90 plus 37. And this angle will be between T2 and T3 will be 180 minus 37. You can ask, sir, how this angle came. I will answer. Otherwise, it's a simple geometry. How this angle is 180 minus this total is 180 minus 37. Now, how to apply this? You can write T1, this is the T1 divided by opposite angle of sine. That means sine 180 minus 37 is equals to. Another tension is T2. T2 divided by opposite angle is what? Angle opposite to T2 is what? 90. That is sine 90 is equals to T3 divided by opposite angle. Opposite angle is 90 plus 37. 90 plus 37 sine. Clear? Out of this, we know the value of T1. T1 is 300. So I will put the value 300 divided by sine 180 minus 37. That will be sine 37. And sine 37 is 3 by 5 is equals to T2. Sine 90 is 1. You know that. Divided by T3 upon sine 90 plus 37. That is cos 37. And cos 37 is 4 by 5. 4 by 5, 5 is in the numerator. Now you want to calculate T2 and T3, you can compare it. If I compare these two terms, what you will get, T2 is equals to 500. And if I compare these two terms, Then I will get T3. That is T3 will be, can you calculate after comparing these two terms, what will be the value of T3? Can someone answer for me? I'm not in the mood of calculation. Can anyone do it for me? Quick, quick, quick. Compare these two terms and you will get the answer of T3. I can see it. 5 and 5 will be cancelled to the 100, 100 into 4, 400. 400, very good. So is the thing clear? We get all the tensions T2, T3 and T1, how to apply Lenny's theorem, when to apply Lenny's theorem. Is everything clear? So our rotational motion is completed. In the next class, we will start another topic, another chapter. Till then, enjoy and do some practice. And I also want to know from which JNV you are, because it will, I should be aware of that before communicating. So I will also want to know from which JNV you are. Okay. Till then, bye everyone. Manipur. Okay. Chichuni, you are from Manipur. Okay, very good. Nisha is JNV Gandhinagar. Okay. And okay, so